which is based upon the principle of superposition of waves. Beat is a phenomenon which is based on the principle of superposition of waves. We have different phenomena based on the principle of superposition of waves, and beat is one of them. Then what do you mean by beat? When two sound waves traveling in same direction, same amplitude, but slight difference in frequency. If M1 is the frequency of first one input, and M2 is the frequency of second one. Slight difference in frequency arrive at a point simultaneously. They interfere each other. Due to interference, the resultant intensity of sound or the resultant wave produced due to these two interference, what happens? The intensity of sound in resultant wave varies between maximum and minimum. Maximum sound is called waxing. And minimum is called waning. When two sound waves of same amplitude but slight difference in frequency interfere each other, the resultant intensity of sound varies between maximum, it is called waxing, and minimum, it is called waning. This effect or phenomenon is called a beat. So what is beat? One waxing and successive waning is called a beat. What is beat? One waxing and its successive waning forms a beat. The number of beats heard per second is called frequency of beat. Then how do we define beat? In short, what do you mean by beat? We have explained. Once again I repeat. When two sound waves of same amplitude, slight difference in frequency, moving in same direction, in same media, interfere each other, resultant intensity of sound varies between maximum and minimum. Maximum intensity of sound is called waxing, minimum intensity of sound is called waning. A waxing and successive waning is called beat. This was an explanation of beat. Then how do we define beat? Beat is defined as alternate rise or fall of intensity of sound. Alternate rise means maximum and fall means minimum. Alternate rise or fall of intensity of sound due to superposition of two sound waves of same amplitude, slight difference in frequency, traveling in the same direction is called a beat. So this is what the theoretical definition of beat. So beat we can prove at which point, at what point waxing is produced, at what point waning is produced. So this treatment we call it as mathematical treatment or analytical treatment. So what is bit of waxing and its successive waning is called a beat. Number of beats per second is called frequency of beat. Now let us discuss. Let us determine analytical treatment for analytical method. Analytical method to determine the beat frequency. To determine beat frequency. Beat frequency. So, mathematical method or analytical method to determine the beat frequency. In order to determine the beat frequency, let us consider two sound waves of same amplitude, say A, traveling in same direction. Slight difference in frequency, say N1 is greater than N2. Arrive at a point in phase. Their displacement from origin is given by y1 is equal to a sine 2 pi in bracket t by t minus x upon lambda. It is the equation of simple harmonic progressive wave. Instead of t, we can write 1 upon t is nt. Since the frequency is different, say n1t. So, y2 is given by a sine 2 pi in bracket n2t minus x upon lambda. These two equations represents, y1 represents the equation of simple harmonic progressive wave of first wave, y2 represents the equation of simple harmonic progressive of second wave, where x is the distance from the origin. Let us suppose a listener or observer is at origin x, is at the position x is equal to 0. He is standing at the origin x is equal to 0. Then our equation becomes y1 is equal to a sine 2 pi in bracket n1t minus 0, or which can be written as y1 is equal to a sine 2 pi n1t, and similarly y2 is equal to x is 0 a sine 2 pi n2t. So according to the principle of superposition of wave, the resultant displacement of the particle at that point is given by y is equal to y1 plus y2. I have omitted the bar. Displacements are given by bar. But the wave is moving in the same direction, in same speed, therefore it is not necessary to denote with bar or vector. So therefore we get y is equal to what? A sine 2 pi nt A sin 2 pi n1t plus A sin 2 pi n2t 2 pi n2t. But sin C plus D, sin C plus sin D is equal to 2 sin C plus D by 2 cos C minus D by 2. So by using this trigonometrical relation, our equation becomes y is equal to 2. In both the term a is common, therefore we get 2a sin 2 pi n1 c plus d n1 plus n2 divided by 2 into t cos of 2 pi in bracket c minus d. 2 pi is common, n1 minus n2 divided by 2 into t. Or by reshuffling we can write y is equal to 2a cos of 2 pi n1 minus n2 divided by 2 into t sin 2 pi n1 plus n2 divided by 2 into t. As we know that initial equations, they are very simple. A sin 2 pi n1t, a by sin 2 pi n2t. The final equation should be simple. So in order to make simple, let us suppose let capital A is equal to 2a cos of 2 pi n1 minus n2 upon 2 into t, and small capital N is equal to n1 plus n2 divided by 2. Therefore, we get our equation will become y is equal to 2a cos 2 pi n1 minus n2 upon t is capital A sin 2 pi n t. So it is the expression for resultant displacement of particle at that point due to superposition of two waves. What physics does it represent? What physics does it represent? This is all mathematical part. We use mathematical part in order to understand the physics. We use mathematical part in order to understand the physics, not to learn the actual mathematics. It is taught in mathematical branch. So, the final equation is y is equal to a sin 2 pi nt. It shows that initial views are simple harmonic progressive view. Resultant view is also again a simple harmonic progressive view. It is still again a simple harmonic progressive view, but there is only change that the resultant amplitude of the wave is A. In initial case, the amplitude of both the waves are same, but resultant wave amplitude is not same because A is equal to 2a cos 2 by n1 minus n2 upon t at t. As the value of cos changes, resultant amplitude also changing. Value of cos varies from 0 to 1. 0 to 1. So, which indicates that in this case, resultant amplitude is changing as per the value of cos is changing. And second factor, the resultant frequency the frequency of vibration of particle is not same. It is the average frequency n1 plus n2 divided by 2. So what physics we are here observing? Two quantities, two things. First, resultant wave is again a simple harmonic progressive wave, but the amplitude is different, which is changing with respect to value of cos. And resultant wave is varying with the frequency, average frequencies of 2 waves. Now let us discuss what in just now I told you. The resultant amplitude of the wave is continuously changing. At some point it is maximum, at some point it is minimum. Maximum is called waxing, minimum is called waning. What is the name of particle? Determination of beat frequency. That means we have to determine the frequency of beat, expression for frequency of beat. Along with the expression for the frequency of beat, we have to show that the amplitude or the waxing and waning are formed. At what interval the waxing and at what interval the waning are forming, we have to show. Okay. Main aim is to determine the frequency of beat. Apart from frequency of beat, we have to discuss the waxing and waning. Okay. Waxing. Waxing is the point at which the intensity of sound is maximum. Intensity of sound is directly proportional to amplitude square. Amplitude square. Resultant amplitude square. Resultant amplitude square. So intensity will be maximum, I max, when amplitude is maximum. Therefore, A maximum, or we can say A is equal to what? The resultant amplitude is given by A is equal to 2A cos 2 pi in bracket n1 minus n2 divided by 2 into t. The A max amplitude will be maximum plus or minus 2A because A is constant. The value of cos is plus 1 or minus 1. Maximum value is plus 1 and maximum negative value is minus 1. So, plus or minus 1 or plus or minus 2A. That is when cos of 2 pi n1 minus n2 divided by t into t is equal to plus or minus 1. When this value becomes plus or minus 1, then A max is equal to plus or minus 2A. And it will become plus or minus 1 only when the value of cos angle cos 2 pi n1 minus n2 upon 2 into t is equal to this angle should become 0. Cos 0 is 1. Cos pi is minus 1, cos 2 pi is plus 1, cos 3 pi is minus 1, that's the result. dash. Or in other words, 2 to get cancels, all pi get cancels. What remains? n1 minus n2 into t is equal to 0, 1, 2, 3, 4, dash dash dash. Or time interval or time t is equal to 0 upon n1 minus n2, 0, 1 upon n1 minus n2, 2 upon n1 minus n2, 3 upon n1 minus n2, dash dash dash. Starting from the origin, that is when time t is equal to 0, first waxing is produced. After time 1 upon n1 minus n2, second waxing is produced. After times 2 upon n1 minus n2, second, third waxing, similarly like this way. Therefore, time interval between two successive waxing equal to difference between these two, capital T. Time interval means time period or time period. T equal to difference between these two, 1 upon n1 minus n2. So time period of two successive waxing is t is equal to n1 minus n2. Therefore, beat frequency n is equal to 1 upon t, or which is equal to n1 minus n2. Or you can say n is equal to n1 minus n2. So what? Beat frequency is difference between the two frequencies of shows. If the difference is 10, we hear 10 beats. If the difference is 20, we observe 20 beats. Let us discuss it afterwards. So we have derived beat frequency n is equal to n1 minus n2. Apart from beat frequency, we have proved or we have derived at what time interval beat waxing are produced. And time t is equal to 0, time 1 upon n1 minus 2 upon n1 minus 3 upon n1 minus so on. Similarly, we can determine beat frequency by using varying. Varying is the point at which intensity of sound is minimum. So intensity is directly for amplitude square. So intensity is minimum. That means amplitude is minimum. Actually, amplitude of wave is given by A is equal to A cos 2 pi n1 minus n2 upon t. So A minimum value of cos is 0. Minimum value of cos is 0. 2A cannot become become 0. Therefore, cos 2 pi n1 minus n2 should become 0. Or a minimum is equal to 0. Or when cos 2 pi n1 minus n2 over t is equal to 0. And this will become 0 only when the angle cos 90 this angle 2 pi n1 minus n2 is angle of cos. So cos 90 is pi by 2. Cos 90 is 0. Cos 3 pi by 2 is 0. Cos 5 pi by 2 is 0. Dash, 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 dash. Dash, dash. So, pi, all pi's get cancelled. 2 get cancelled. Pi get cancelled. What remains? n1 minus n2 into t is equal to 1 upon 2. n1 minus n2 t is equal to 1 upon 2. 1 upon 2. 3 by 2. 5 by 2. Dash, dash, dash. Or t is equal to 1 upon 2 n1 minus n2 for first value. Second value is 3 upon 2 n1 minus n2. Second value, third value is 5 upon 2 n1 minus n2. Dash, 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 so on. Similarly, time interval between two successive varying or time period of beat t is equal to difference between two. 3 by 2 minus 1 by 2 is 1. 1.5 minus half is 1. We get t is equal to 1 upon n1 minus 2. Or beat frequency is equal to 1 upon t is equal to n1 minus 2. So, with the use of from the concept of ballooning, we also proved that beat frequency is equal to n1 minus n2. That is difference between the frequencies of two waves. So, we have proved or determined the expression for beat frequency, which is n is equal to n1 minus n2. How much is that? You put this. Okay. So let us discuss something about beat. What is beat? The alternate rise or fall of intensity of sound due to superposition of two waves traveling through the same medium in same direction but same amplitude and slight difference in frequency. Slight different in frequency. In biology, you might have studied or you might have come across the dialogue heartbeat. Heartbeat. Why the sound of heart is given as heartbeat? Is it related to the beat which arises in physics? So, it is better to ask your biology teacher why we call it as a heartbeat. Now, just now we proved that beat frequency n is equal to beat frequency n is equal to n1 minus n2. A human normal ear can detect maximum 20 bits, not more than 20 bits. Why? What would the reason behind it? With the beat frequency, the difference between the two beats is, if it is 20, beat frequency is 20, then only we can detect beats. Because the time period for one beat, if 20 beats are produced in 1 second, for one beat, for frequency time period t is equal to 1 upon n or 1 upon 20, or which is equal to 0.05. Second, if 20 beats are produced in 1 second, maximum beats a human normal ear can detect maximum 20 beats. So time period of one beat is 0.05 seconds. More than 20 bits cannot be detected, because when sound receives on the ear, in the ear, the energy, the message has to be transferred to the brain, that there is some energy has been intercepted on the ear. In order to transfer the message, the time taken to receive the message is 0.05 seconds from ear to brain. कानापासून ब्रेन पर्यंत जाण्यासाठी लागणारा टाइम 0.05 सेकंड आहे. त्याच्या आतमध्ये एखादा जर मेसेज आला की आपण डिटेक्ट करू शकत नाही. सो वॅक्सिंग आणि वेनिनिंग मधला इंटरवल 0.05 सेकंड असेल, वॅक्सिंग नंतर वेनिनिंग मधला टाइम इंटरवल किती 0.05 सेकंड असेल तर आपण डिटेक्ट करू शकतो. If it is less than 0.05, brain cannot detect the message between less than 0.05. So if you talk slowly, giving space, you can hear it properly and you will identify the words. If you talk fastly, you are not able to detect, because in order to receive the message from ear to brain, the time is 0.05. Within that, if second message is received, it cannot be detected. So the maximum number of beats a human normal ear can detect is 20 beats per second. Beats may form 100, 200 like anyway. The difference is large, but human normal ear cannot detect it. Okay, today let's stop here only. Let us discuss it tomorrow. Bye.